Hello everyone. In this video, we will be covering the second part of variables, data structures. I think the best way to describe data structures is that they are basically just a type of container. They provide us a way to store and organize a huge amount of data and make it very efficient to access and modify the data stored. Data structures can store almost anything too. All of the data types, all of the data structures, objects, and so on. They basically make it so we don't have to manage literally 1,000 different variable names in our code. The four types of data structures are lists, tuples, dictionaries, and sets, and we're going to start with lists. Lists are an ordered and mutable data structure. That's right, mutable. Lists can be modified without having to reassign them. However, the data they may contain can still technically be immutable, such as integers, strings, and floats. Ordered means that the order of items in a list will not change without the help of certain functions. In general, when new items are added to a list, they are added to the end. Lists are also indexed, which means that the elements of a list can be accessed through indexing. In order to tell them apart from other data structures, they are characterized by square brackets. And on top of being able to store anything in a list, you can have duplicate items in a list as well. To create a list, you can either use the list function, an empty set of square brackets, or in like these two examples, you can have square brackets but populated with data. And if I print these out, we got empty square brackets here. We've got a list of numbers, and we got a list of basically everything, just basically showing that all the data types, well, this isn't all of them. I left out complex and some other things, but pretty much anything can be stored here. We got data types, another list. This is a tuple, and this is a dictionary. And then to access items in a list, you can access them through indexing, as mentioned earlier. So basically, you just have the name of the list variable, open a square bracket, put a number inside, and then close it, and then that's it. So this is a list of 4 items, so 0, 1, 2, 3. So 1 is frigate, as you see down here, and 2 is destroyer, as you see right here. To add items to a list, we can either append, insert, or extend. So appending just is the normal function. You basically append an item to the end of the list. Insert allows you to specify a specific index in the list that you want the data to be put in. So this first item here, this is the index. I probably should use strings for this example, but this is the index that we're telling it to put the number in, and then this is the number that we're going to put into the list. Extend allows us to take another list and take those items and add it to the list we're extending. So we can extend by a list literal, or we can extend by a list variable. It's pretty much the same thing. And I can show you by running this. So as you can see, we created an empty list and we added 1 and 2 to it. Then here at index 0, which is here, we added a 3. So it pushes the 1 out of index 0 and puts the 3 in index 0. So nothing gets deleted. When we say insert, it's going to insert it at that point, and it will push all the items that are already in the list to the right. So 1 got pushed here and 2 got pushed here because we also inserted a 4 at the spot of 2. Extend, we extended 5, 6, 7, which you can see right here was added to the end. And then we extended 8, 9, 10, 11, which is also here. And then when we append a list, it's not going to add these items to the list. It added the list itself into it. So now we've got a list of integers and a list. To remove items, if you know where the item is located, you can refer to it by its index and use the delete command. So we have the delete keyword right here. We put in the list followed by the index. So when we run this, 3 will be deleted from the list. We can also, if we know the value of the element in the list, we can remove it by the value. So here we say we want to remove 2, so 2 will be removed. And then here we say to remove 1. Now you notice that we have 2 1s in the list. It will only delete the first one it comes across. Once it sees this one first, it will delete this, and then this 1 will still be here. And since we didn't touch 5, 5 will still be there. So when we run this list, we should have been left with 1 and 5 at the end here. All right, next up are tuples, also sometimes pronounced as tuples. Those are both accepted pronunciations. They are similar to lists, except they are immutable. They can be created with the tuple function, an empty set of parentheses, or a set of parentheses with, at a minimum, 1 item followed by a comma. It's important to note that you must have that comma, otherwise it will not be recognized as a tuple. And I believe I have an example right here that shows what happens if you leave out that comma. We've got an empty tuple, We got a tuple with one item, a tuple with multiple items, and a tuple with multiple items of different types. So if I run this, so we got a couple empty tuples, we got all this, and we got this. And as you can see here, the difference between seed tuple and not a tuple is that there's a comma in seed tuple. So this was printed out as a tuple, and this was just printed out as a 1 right here. And if we printed out the type of not a tuple, and it shows that it came out as an integer. In fact, let me add a line right here. Where did it go? There we go. Type C tuple. So now we run this again, and you see as compared to not a tuple, that was printed out as a tuple. And so that's only if you have one element in a tuple. If you're creating an empty tuple, you don't need to add the comma. And as mentioned before, tuples are immutable, which means you cannot delete or add items to them. So if you need to update a tuple, you have to reassign it. So as you can see here, we've got a tuple, and then we got this line here where if I attempt to delete an item from the tuple, it will throw an error. See, it throws an error because we can't delete that specific item. But we can prune a tuple with index slicing. So as you can see here, I just specified a new tuple with the new elements. So it starts from 2 up to, but not including 4. So index 4 is 5. But when you specify the indexing like this, this does not include 5. This will include up to 5, not including it. So this would just be 2, 3, 4, as you can see here. If we wanted to include 5, then we would have to say 1 to 5. Now, even though we can't delete items like this, they are still indexable, so we can still use indexes to access them. So we can print out the individual tuple elements. Now let's talk about the dictionary, which is my personal favorite data structure. Dictionaries are basically a hash map data structure consisting of key value pairs. They are characterized by curly braces and using colons to pair keys and values to each other. The keys must be unique. Attempting to use an existing key with a different set of data will cause the old data associated with that key to be overwritten. Because a key must be used to reference the value it is mapped to, the key must be an immutable type. You can pretty much use anything, almost anything, I should say, for a key, but as long as that key is an immutable data type. So integers, strings, floats, even tuples can be used as a key. You cannot use lists or other dictionaries, and you cannot use a tuple if it contains a list or dictionary inside of it. Got some examples of creating dictionaries. So we got an empty dictionary here, another empty dictionary, and then we got a dictionary with some data inside it. So if I print this out, we got 2 empty dictionaries and this dictionary here. So you can start off with an empty dictionary and basically assign items to it. And it's nothing special. Basically, if you know what key name you want to use, you just basically put that key name there in square brackets, and then you assign a value. And we can assign more stuff, and we can pretty much assign anything. So this one is basically me creating another ship dictionary, and then this one's a sample dictionary showing how you can pretty much assign anything to a dictionary. See, so we assigned a name, then we assigned more stuff, and then we created a dictionary with a whole bunch of things. So this is a dictionary, this is a tuple, and oh yeah, this is a tuple key, and then this is a tuple. Unlike tuples and lists, we do not have to, we don't have to, we can, but we don't have to iterate through a dictionary to access items. As long as you know the keys, you can access the item directly. So I've made a sizable dictionary here. It's nonsensical data, but I figured to keep up with the theme, we made a dictionary for a space station. So station name is assigned Wayfair. We've got docs, which is assigned a list, and the list is a list of dictionary items for that have descriptive information for 2 docs. And then we have another dictionary here. This could have probably been a list too, but I chose to make it a dictionary to like really show how nested dictionaries work. And we got the dictionary quadrants, and then we have multiple quadrants also assign dictionaries in here. And inside of them, we have living quarter capacity. So we got the key docs, which is this, and it goes to this list. And since it's a list, we use an index. So we index 0, which is this one here. And then we access the name key, which refers to this key here. So when we print this out, it will say alpha doc. Same thing here. We go to docs, index of 1, and then we access the name here. So we're going to get alpha doc and bravo doc. And then here, it's just straight keys. So we got quadrants, which is a dictionary. We got quadrant 1, which is also a dictionary. And then we access living quarters, which is an integer with the value of 200. So when I run this, alpha doc, bravo doc, 200. So that's how you would access items in a dictionary. And deleting dictionary items, it's pretty much the same as deleting elements in a list. If you know the key, you can specifically delete that key value area. So I create another dictionary, print it out to show you the full contents. Then I delete type, and then I print it out again. So as you can see here, we've got type missing from here because we deleted it. And finally, we have sets. Sets are immutable, they are unordered, and you cannot use indexing on them. The only way to go through a set is to iterate through it. So even though they use curly braces when populated, they are not characterized by empty curly braces. When you want to create an empty set, you can only use the set keyword. Attempting to use curly braces will automatically turn it into a dictionary. But you can use curly braces if it's going to be curly braces that's populated with data and the data does not contain colons. So we got an empty A set, a populated B set, and a populated C set. So if I print these out and then iterating through a set, so we got a set here. This is a for loop. We'll get more into those when we actually talk about loops. I only put this here because I wanted to show you how you would iterate through a set. So if I run this, we're going to first get an error because I'm trying to print out an index, which as you can see, we cannot do. Comment that out, and then we go to the for loop. It prints them all out. So we can iterate through it. We just can't access it by indexing. You may have noticed that I have a bunch of ones, a bunch of twos, and a couple of threes. But when it printed out this set, it only printed out one of each. Items in a set are unique, so you cannot have duplicates. If it sees duplicates in a set, it will automatically remove them. It won't even throw an error, so that's something you have to be careful with. This can be useful if you want a fast way to prune a list, because you can cast a list into a set and then cast that set back into a list, and then you'll get a list without the duplicate items. But if you want to have a data structure with duplicate items, use something like a tuple, a list, or even a dictionary, as long as you don't use the same keys. But do not use a set, because a set will ignore the duplicate items and only store one instance of each duplicate. So you got 1, 2, and 3. That's it. And that's it for the basics of data structures as well as variables in general. There is a lot more stuff you can do with everything covered in both parts, but I wanted to keep both parts at a reasonable size. All of the stuff that hasn't been covered in these two videos will either be covered in their own videos later on or in videos where they fit in with a given topic. If you've enjoyed this video and found it helpful, then please leave a like. If you want to see more, then head on over to Wayfair Coding Academy channel to check out my other content. And while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. And be sure to leave a comment below to let me know what you think. Thanks for watching, and I'll see you all next time.